This conference will now be recorded.
Good afternoon, everybody. All right, so today we have one presentation from Mark from WD. And before I turn over to him, just want to remind everybody that we have the summit next month, and that's on the second week. That's, I believe, the 14th and the 15th of March. I sent out the cancellation today. There will not be an OCP monthly call in March because it's the exact same time as the summit. So are there any questions about the summit, about the storage track, before we go into the presentation for today? Going once, going twice. All right, well, I will turn it over to Mark and make him the presenter. All right, Mark, torch is passed to you. Mark, we can see your screen, but we can't hear you.
What did you want me to say?
Ah, there you go. All right. Everything was
No, yeah, different Mark. Sorry, I didn't realize I was muted.
That's the wrong Mark.
So I am Mark Miklon from Western Digital. Are you hearing me now?
Yes.
I can hear you.
Yes. Okay, perfect. Thank you. So I actually have two presentations. I don't think that they'll be too long unless we get a lot of questions, but I do welcome questions. I have two proposals for submission to OCP storage. The first one is a specification for a programming interface, and I'll walk through that. And the second one is a more traditional mechanical design. All right, we have been working for some time now on an API for open composable systems. And what we've realized is that there are various options for hardware composable systems in the industry today, although they are generally not open. And what I mean by that is they're branded by a vendor, and they come with tools and controls and everything that are part of that brand and part of that vendor's offering. So what we have come up with is an open mechanism to enable similar types of things, and I'll get into what this is, but we're talking about orchestrating virtual systems from disaggregated hardware components. And we have this interface developed and running on some hardware today, and we would like to submit this and donate this through OCP to the open community. And our goal is sort of stated here at the bottom. We want to enable virtual systems composed of disaggregated compute, GPU, FPGA, memory, and storage, all from different vendors, and make that become a reality. So this is just a sort of an example or a description of what we're doing. On the left are sort of standard or traditional storage architectures. We have SAN, we have direct attached storage in a server, and in particular, NVMe Express and SSDs that run NVMe have become very popular as a low latency, high performance path in that direct attached model. The one issue with that model, though, is it does not scale widely. And so NVMe over Fabric has gotten a lot of traction as a mechanism to scale that. And the composable systems that we're proposing all use NVMe over Fabric. And again, we're very big on it being open, scalable. The disaggregation I'll talk about in a minute, and it is extensible. So we have flash today, disk, and other types of storage are certainly possible using the same mechanism. What's driving this are some of the things you see on the left here. So SKU proliferation, stranded capacity, and unpredictable growth. So we see a lot of attempts for data centers to limit the number of SKUs of hardware that they bring in. And each SKU of server might have a different objective or be optimized for something different. But in the end, that can grow, and it's not always a situation where you can meet all your needs with 3 servers or 6 servers or 10 types of servers. And so what happens, you end up with a lot of different server configurations around, and then stuck with the issue of having to manage those different things over time. We also see a lot of stranded capacity. So if say a 24 drive server goes in, those 24 drives may not all get used for the application that server was targeted for. And so there's attempts to reassign, reconfigure, change that over time, and the tools to do that are not always there. And then the predictability of the growth and the capacity is always difficult. And so this open composable model provides a mechanism to just easily add compute or storage as you grow. So just some tenets here of what we're proposing. What is a disaggregated resource? So to us, this is a simple type of resource that is available in a pool, and we've listed them here. So storage, compute, network, memory, and controlled power could be considered as well. Fabric attached. So there are many types of fabrics out there. The contributions that I have do not necessarily limit themselves to any particular fabric. We are developing or implementing it in Ethernet, but it's easily applicable to these other things as well. So self-partitioned, what we mean by that is a device that is going to be composed with this API has to be able to virtualize itself, has to be able to partition its resource into usable segments and offer those segments to the composition layer. Multi-tenant sharing, so that kind of goes without saying. We want multiple applications to be able to get into the same storage or different elements on the fabric as well. And it's sort of a mechanism to keep it simple at the same time is to be device focused. And so every device that this API is written to control has a single function. So for example, the storage does not also include data protection. Data protection would be another layer in the solution, not something that the device itself would necessarily do. Any questions? I'm going to get now into more, precisely what we're offering or what we have. But any questions on why we're doing it at this point? Okay. So what we're contributing is the gold box in the middle here. So we have this open composable API. It's based on HTTP, SIM, REST, and JSON. So all those is sort of our guiding principles of how we've developed the open composable API. What's important to note is the API does not actually do the composition of the virtual systems. So what we have here are commands, protocols, you might say, for a composition layer to come in and control an individual device, ask the device what it can do, how much it has, those kind of things, and then carve out a namespace in the case of storage or some amount of compute in the case of a compute device. But there needs to be a higher level entity that actually is doing that composition. There are commercial products out there that do it today. Some people do it with their DevOps people inside their own data center. But so we're kind of stopping at the API level and not trying to take it up into the complete solution space. And again, just to sort of get some terms straight, when I talk about a disaggregated device, today, for the most part, these things are all together in one piece of sheet metal we call a server, right? We have CPU, you can plug in GPUs or FPGAs, and it has memory, and then flash or disk or some of both. But as you're going to see, what we're talking about is breaking those out of that sheet metal, providing a mechanism that they can each exist on their own. And then when we talk about composability, how much of each of those resources do you want to pull together into a virtual system? And so if we take that same sort of server model but break it into its disaggregated pieces, it looks like this. And we can connect all those through one of these fabrics that I mentioned. Some examples. So consider these the pools. So we have 5 slices of CPU, 5 slices of GPU and FPGA. We have some memory, and then we have storage on the right. And so if a composition tool were running the API, it could come in and say, hey, I want to build virtual system number 1. And here we've picked off 1 CPU core, some GPU, some FPGA, and some memory. And that's our first virtual system. And that system can be used for a long time, for a short time. Whenever it's done, there's a mechanism in the API to return those resources back to their pools. And so then virtual system number 2 can get constructed, and you see we just have different amounts of the same elements because this system is needed to do a different application, and on and on. And so we show 4 of them here. And the API allows you, as I said, to sort of pick out these individual disaggregated elements and virtualize a system to run an application. So what is it that we're talking about? What is in this API? And so one of the keys for us is we've relied on REST. So REST is a principle. It addresses these 4 key tenets, so addressability, statelessness, connectedness, and a uniform interface. And we've been very strict on this. We've tried to not deviate from REST in any way. We have simple URI patterns for all the resources. It is sort of very performant and designed for large scale. The model is very simple, and we tried to reduce any complexity anywhere we can. As we'll see when we get into the document, these messages and constructs are quite clean. Yeah, and it's even it's all human readable, and we even have a GUI or a browser interface into it as well. We've also used the Common Information Model. So this is something that's been standardized in DMTF for some time. We have done some optimizations to the Common Information Model, and they're listed here. I don't necessarily want to get into the details of what these are, but this is all done in the name of simplifying the whole mechanism. So I don't know if anybody is extremely fluent in SIM, but you might recognize these things if you are. And here's some examples or some descriptions of the verbs and the responses that we've used. So again, standard HTTP responses and standard REST-based actions and verbs. And so what have we done from a URI structure point of view? Again, it's all laid out here. To really get into this, I think I need to be able to post the document and let people see what we've done. But in essence, we've created mapping and a mechanism to get to all of the device types that I mentioned. So storage, compute, network, and the virtual system are all there. There's get and put and different responses to the various commands for all these things. And one of the things I would like to benefit from by putting this in OCP is to get more feedback on it. So we've we've worked with a few partners to get some feedback on it, but I think in OCP, there's going to be people who are compute experts, people who are networks experts that we at Western Digital may not be, and will provide a lot of valuable input and changes to this spec as we go forward. So again, without getting into the details of what the actual constructs are in the specification, this is as far as I wanted to take the presentation today, and I'm requesting that OCP Storage consider accepting this project.
This is the other Mark Carlson. Can I ask a question?
You bet.
So who has change control over the actual document? Is that part of this group now?
And again, I'm a bit of a newbie to OCP, so I apologize if this is not the way it would work. But what I would like to do is actually run that in GitHub. And if
no, that I'm not asking where, but I mean, would this group designate, the contributors to it and handle it in GitHub or wherever?
I don't want to limit any contributors, but I would like to use GitHub to ingest different streams or changes. And yes, this group could.
Yeah. So then we, as a group, would approve the pull requests, right?
Correct.
Okay,
yeah,
that makes sense.
Yeah, so OCP has a GitHub, so if you wanted to do it in GitHub, that's fine.
That would be the
we
best
already have a
place,
GitHub place, so, and then you would basically, drive it there.
Right.
Okay.
All right, thanks, Mark.
All right, any other questions for Mark?
Will you post these slides? Or how do we see these in the future?
Yes, if there, again, I'm a bit of a newbie. If there's a way for me to post them directly, I will, or I can give them to Jason.
Just shoot it over to myself and Georgie, and we can post it up on the wiki.
Okay, perfect.
Yeah.
All right, I will move on to the physical device presentation. Okay, so we also have a physical device that today embodies flash storage. It is extensible to the other elements we just talked about. But again, what we're addressing is composable systems today are not truly open, and we want to see that happen. Similar description. This one shows two fabrics, which is a possibility. Again, it's not something we've implemented yet today, but one of the pushbacks we've gotten on this concept is a data fabric may have more latency, and you may want a specialized memory fabric, which is fine. That totally fits within the architecture. But what we have here today is a physical form factor and a mechanical design to accommodate a device. Again, it's agnostic to the fabric. So we are, as far as the product goes, Western Digital is implementing Ethernet and have already announced that, but these other fabrics are possible in the same form factor. We are rolling it out in a standard 19-inch rack, but there's nothing about this device that would keep it from going into the OCP rack. This is a very low level of detail on a mechanical design, but it is the rough outline of it. You can see in the upper left is a picture of this mechanical enclosure. It's roughly 1 U in width and 3 U in height. You can see the actual millimeters there on the right, and it's 2/3 of a meter deep. So it's a fairly long device. And I have a slide at the end that'll show you, kind of what kind of things can you fit in there. Because we have attempted to make this fairly universal and support a number of different fabric attached devices.
Mark,
Some other,
we go
yes.
back to the
Yep.
So you have mechanical dimensions. What about the thermal and power capabilities that you're building into the chassis? Is that later on in the slide deck, or?
It is not. And so what we have done is I do have there is a limit in terms of the connector that's in there, how much current can go through it, but the airflow is not really even a part of this device. So this device needs to be inserted into an enclosure. Western Digital has one design of that enclosure. There could be many designs of that enclosure, and that enclosure has to handle the thermals. And so depending on how much power you're going to consume in the device, it will be a factor of how much air and what temperature air you want to assume, and all those things come into play. So I did not intend to specify that as part of this design submission, because they're actually controlled outside of this design.
What about like SFF? Would that be a good place to take that?
We actually are. So in SFF, I have 3 projects running right now. One is the same mechanical design. One is the connector that goes on the back, and then a third one is the pinout to that connector. I don't know that I can. I didn't put that on a slide because I think I don't know if I can talk about it outside of SFF, but
Oh
I
yeah,
guess
all
I broke
SFF
that.
stuff is public. Even the draft stuff is public.
Okay. So yeah, there are 3. The project numbers are 1013, 1014, and 1015.
That's
Okay, these are just some a little bit better pictures. So you can see the enclosure. Our design holds 10 devices, and again provides the power and cooling for those 10 devices. So each individual device has no fan in it. It just holds electronics. And again, we would provide the design of this sheet metal enclosure, and then through SFF, people could get the pin out and the connector definition as well.
On the power issue that somebody was asking about, is it typical when somebody contributes, or is there no? Maybe there's no typical, but when someone contributes a hard design like this, is it typical that the airflow and all that be part of it? I mean, or I'm just trying to understand the motivation for the question.
So I think it's fairly important to understand the power and thermal envelope. So I know that you mentioned the chassis. Mark, chassis actually has the airflow in it. However, if someone wanted to build one of these sleds, they need to know what the max power envelope is. So that'll be the connector will define the power envelope. Obviously, your pinout will tell you your interface to it. But if the airflow is not sufficient, let's say you could cool 150 watts per sled. If someone's not aware of what the cooling capabilities are, they couldn't even begin to start a design. If you want to have this as an open standard, I really think you have to have the airflow patterns that would go through this. So if all sleds were the same, do you have any baffling between them? What is the guaranteed CFM? Things like that would make it easier for someone to design a module. Without that, I don't see successful third-party adoption of this to build these modules.
But even if the module was self-contained for its cooling, still the air has to be there on the inlet and has to be exhausted on the outlet, and there's system level planning to be done for that.
Okay, well, I think Western Digital would do that. I'll have to discuss that with some people here before I can commit to it.
Yeah, Mark, we have that information. It's just a matter of figuring out what part gets specified where.
Yeah. Okay, this was the last slide I had. So one of the questions I get as I discuss this is, most commonly, Well, how come? Why don't you just use EDSFF, which is another standard out there that is getting developed? This is a much larger, sort of a different class of device, I would say, than any of the EDSFF form factors. So you can see sort of the bottom here, even the long ones, you could house in this enclosure at least 12 of them. The short ones, you could probably do either 24 or 36 of them if you could find a way to cool them all. And then M.2s, we've got a design there showing up to 40 M.2s in there. So it's a very different size of device, and so the amount of, in the case of storage, the amount of capacity you're going to have in one of these is 12 or 24 or 50x what you might have in a more common and a smaller storage device that you're used to today. And then I did some research on motherboards, and so to put a compute into this form factor is very reasonable. So there's 800 square centimeters of board space if you just had one board sort of occupying the enclosure, and then there are motherboards that have more board space than that, but there are certainly motherboards that fit under that as well.
So is your connector specified such that it can work with more than just Ethernet?
Yes. So the connector, and again, this is running in SFF right now, and I didn't realize I could just bring it in here before that was done. But it is.
You can share it.
It is specified to match directly. So it maps directly to 2 individual QSFP28 housings, and then in addition to that, it gets power and some low-speed interface from so in our enclosure we have a BMC. That BMC runs some I2C and UART and things like that to all the devices. And
so you know about the Open BMC project?
I do know about the Open BMC project.
Yeah. And so is there any plan to make that work with this?
I have not scoped that.
Okay. But like on the 1002, the signal integrity requirements are there. Are those similar to your connector?
They would. I mean, this connector supports 100 gigabit Ethernet. It supports the fastest fiber channel that's out there. It supports PCI natively, which is what 102 is talking about. So yes.
Okay, great. Thanks.
Okay, Jason, that was the end.
Thank you. I actually do have some more questions. You partially addressed that. So the systems management aspect, there's already a proposal you do consider OpenVMC because that's obviously helpful. People have a lot of familiarity with that. But if you want to make this an open spec for the sleds, having that management interface is going to be important as well.
So what's the specific ask there?
So I think what I would do is put on, if you were a third-party customer hat, you see this platform, the solution looks really good, you want to build your own sled. What do people need to know to build their own sled to go in this? That goes back to the thermal questions from earlier. Just what else, if someone was not a Western Digital employee, if they were looking at this and leveraging your chassis and they want to build this new module, let's say it's a machine learning accelerator, for example, how would they get started? Those are some of the considerations you may want to put into that.
Okay.
I think a bunch of people on the call have already brought up some of these what ifs, and I'm sure there are a lot more that if you had maybe a first proposal of what you're looking to open up, we could probably, as a group, give you some feedback on what else we would like to see.
Okay.
Anybody else on the call have any other ideas that we should at least let Mark know up front, things we haven't covered yet?
Yeah, Jason, this is Archana. I was also going to suggest that he work with somebody in our hardware management group to see if they have profiles for, say, storage, like Redfish profiles for storage. or swordfish and see if this is part of that ecosystem? Because I know they're working on profiles. I know they're working on server. I know they're working on network switches. I know they're working on rack and power. And I thought they were also working on storage. So it'd be good to know and just connect those
Yeah,
dots.
they are. We've actually had some of those discussions with different DMTF members who
Uh-huh.
are developing redfish and swordfish. There's a fundamental difference and this goes back. This isn't so much about the mechanical presentation, but about the API. Redfish and swordfish require a service endpoint. Now I know there's some discussion about a light version that may not require the service endpoint or getting rid of the service endpoint, but as it exists today, they all require a service endpoint, and then that service endpoint brokers the redfish and swordfish interface to whatever's behind it. These devices are all peers. And so every fabric attached device that would be using the API needs to digest the API and respond to the API itself. And that has been a fundamental difference. Now, could you accomplish the same thing and always require a service endpoint? Yes. But that was one simplification that we made as we went through our design is, we felt we really didn't need the service endpoint to accomplish the composability aspect. And so we took it out.
You mentioned a BMC, but that's out of band management. Or are you saying the preferred method is in band?
It can be in band or out of band. That actually is, we're agnostic, and our devices do both. But even when the BMC is there, in the sense of what it's doing for the API, it's really just passing. So if you come into the enclosure through the BMC and you're running open composable API commands, they just get sent to each individual device. So our BMC has a router in it, and it would route your command to each individual device. It doesn't translate it. It doesn't do anything with it the way if it were a redfish command coming in, it would do that. It would do some translation on it.
Okay, let's say that the sled is talking NVMe MI. Is that can I come in via NVMe and MI and manage the sled, the storage sled? It's all NVMe stuff, right?
Yes. If the sled supports NVMe MI, and I'm a little bit out on a ledge here. I'm assuming that NVMe MI commands would get are supported by NVM over fabrics, which I believe they are. Then yes, you could come in with NVMe MI commands. But to my knowledge, those commands aren't really set up to orchestrate virtual systems. They're set up to manage storage.
Well, yeah, there's admin commands to create namespaces and so forth, right?
Correct. Yeah.
So you can do all that in band.
Yes.
And like you said, you can issue an MI command in band. It's one of the features of the spec.
Yep. Yeah, so that would all work.
So if you're talking Ethernet then on a storage device, you're talking Rocky?
Yes.
Somewhere in there? Somewhere in the sled?
Yes. Yes, our product terminates Rocky.
So in the actual chassis itself, you have the Ethernet fabric, right?
So let me back up. When you say the chassis, which one of these are you meaning?
Not the subcomponent, but the main sled design. The big chassis.
Our enclosure, we call it the E3000, there's no switch in there. So every device is individually just cabled out the back to an Ethernet switch. Now, somebody else could design one that does what you're saying. That's just not what we have done.
Okay, without a shot of the rear, it was hard to tell. I assumed that you had a fabric of some sort.
Sorry, I could have put that in, but no, we're using a fabric, but it's external.
Okay, so in the back to connect into it, so essentially each one of these sleds slides in. There's a mating element that then gives you a QSFP per sled out the back?
Actually 2, but yes.
2 per, okay. So it's a bunch of connectors out the back.
Yep.
I think someone earlier asked about signal integrity requirements, so that would be an interesting one. And I'm assuming the design you have here, is this a 19-inch rack compatible? I think you mentioned?
It is. Yeah.
Have you considered something that would fit in an open rack? So if you have the extra width, could you bring out the QSFPs in the front somehow? Might be difficult if it's the connectors in the back without a fabric of some sort built in, but you might want to consider that many customers would like to see it in the front versus the rear, at least for the hyperscalers. Obviously,
Okay.
enterprise customers less so, but hyperscalers, we certainly prefer it in the front.
Thanks for the feedback.
Any other questions for Mark?
Has there any ecosystem been developed around this? Are there any ODMs or even hyperscalers on board with the design?
We have been working with a number of people. At this point, I cannot name them, and that's another reason why I would actually like to get these things into OCP and have more of an open discussion, so more people can participate sort of in parallel or in a group fashion.
Well, yeah, I mean, we'd all like to make one version, one SKU of these things if we could.
Right. Yeah, we're very interested in that as well.
That's a very neat design.
Thank you.
So Mark, what are you looking for the community? Are you looking for people's input? Are you looking to share more details and just get people to look at that? I mean, what level of collaboration are you looking at?
Yeah, I would love everyone's input, particularly on the API. I think assuming we can put enough information out there to allow others to develop the physical devices. That is probably pretty straightforward. And again, we're looking to standardize the individual device, not so much the enclosure, because there's a lot of I think there's more chances or more ability to differentiate products in the enclosure. And so I don't want to limit that. But so the API specification, I would like to get out there and start collecting feedback and see revisions made to that spec.
Yeah, we want a forum in which we can talk about the API spec and get public, feedback with an IP, framework and everything. That's one of the key goals.
And I think that there's enough interest. I mean, having a subgroup where people who are interested specifically in the APIs, if you want to hold weekly, bi-weekly, monthly, that might be a great opportunity to do that.
Yeah,
so,
I would take you up on that. Yeah, I would definitely do that.
What I would suggest is maybe gather some of your thoughts, and so we'll be able to post this on the wiki. Have some of your thoughts. You can send it out to the storage mailing list, and if you get enough interest on the mailing list, then I would suggest we, set up a subgroup for you. And if you're willing to host that and run that, I think that'd be a great opportunity.
Okay, thank you.
And then it sounds like on the hardware part of it, we need to do a little bit of thinking about the fleshing out the content of the kit, that we submit, so that like with the airflow and the other things are raised, right? And
the mailing list is a great way for that. You can maybe list out the things you're thinking of opening up, and I'm sure people will comment back with areas they'd like to see a little more details on.
Cool.
All right, if there are no other questions, then I would say, Mark and Dave, if you want to send out a note to the mailing list, send me or Georgie the slides, and we'll be able to post these up on the wiki.
Will do.
All right. Thank you, everyone. Hopefully see many, if not all of you, next month at exactly this.
Yeah, I'll say this.
Right.
I will have examples of this on the exhibition floor in the summit.
Awesome. Perfect. And actually having that subgroup might be helpful because then you could even have information that, are you interested? Do you want to participate and contribute? And you can actually point them to the subgroup.
Exactly. Thank you.
All right. Thanks. Thanks, everyone.
Right.
Okay.
Thanks. Bye.
Bye.
Bye.